learning how to integrate electrical and mechanical design using SOLIDWORKS Electrical. I'm Joelle Guinette. I am the Territory Manager for Eastern Canada, which goes from Ontario to the Maritimes, and I have with me JP Emmanuel, who will be doing this demonstration, and of course Michel Cloutier, who hosts each of these calls with me, as he's the technical manager for Eastern Canada. As we travel together to visit you guys, we learn a lot about what you do, what you can do, what you can't do with what you're doing today. And one of the main things that we hear a lot is the integration of different departments, different tools, different collaborations that companies are trying to do. And one of the most important ones that we see day in and day out is electrical and mechanical. So as the video you've just seen shown very clearly, these departments have traditionally worked very much isolated in their own worlds, and at some point have to come together. And then at some point, reworks have to be done because the collaboration just wasn't there, wasn't as efficient as it could have been, wasn't as simple as it could have been. So we're trying to fix all of these things, and we're going to show you today how we can do that working with SOLIDWORKS from a mechanical perspective and SOLIDWORKS Electrical from your electrical perspective. We're going to use, or JP is going to use a very interesting example of brewing beer that he's designed at his place, and this gets us kicked off for the weekend after that. Hopefully we won't get you guys too thirsty too quickly. But let me introduce, hang on. Before I introduce JP, just going to go through a few things of logistics on your window for GoToMeeting. There are some handouts, so feel free to download those at any time. I think there's 3 handouts that are available there. There's also right below that a chat section. So if you have any questions at any time during this presentation, please don't hesitate and type them in there. And we'll check at the end if they have not been covered during the presentation. JP will answer them. And if it goes into a longer conversation, then we will take this offline with you and be able to address them more individually with you. But please feel free to ask your questions there at any point in time. All right, so with that done, JP comes to us with a very peculiar, very interesting background, which I love, being in the naval service of the United States and working on submarines. So I have always been very fascinated by submarines, as I think many people have. Love to be able to do tours when you go visit some of the coastal areas, either in Canada or US, where you can actually board a submarine and see what they look like. So JP actually got to work with them and go around the world a few times doing this service for the United States. And with that, he learned electrical design in submarines and in other areas. So you're going to see all of these. He's possibly going to give you an example at the beginning before he starts. You never know. But he's been with us with SOLIDWORKS for a number of years and has lent his expertise in electrical design to SOLIDWORKS in North America and helping customers understand how the tools can work together and how they can improve how they work today. So without any further ado, I will turn this over to JP, and I'll be back at the end to close off the webinar. JP, to you, thanks.
All right. Thank you, Joelle. All right. Well, thank you, everybody, for joining me here today. As Joelle mentioned, my name is JP Emmanuel. And I'll continue to add some extras into who I am, what I do. I actually live in Connecticut. I was stationed in, as you can see there on the map, New London, which is the largest submarine base in the United States. Grew up on Long Island, joined the military, see the world, or just essentially moved 2 hours away from home. That's where I ended up. And now I'm there with my wife and kids. And as Joelle mentioned, I was in the Navy. This is us up in the North Pole, north of where many of you are right now. And then from there, I became a defense contractor working for that company called Secor. And I did a lot of one-off designs to start, a lot of R&D work, a lot of white paper, just ideas, trying to come up with new ideas for the military, and taking those ideas and turning them into full production. For example, that cabinet we see on the left, it started out as just a basic idea. We did all the initial designs for it. We prototyped it and got to the point where we were assembling. We ended up building 46 of those and put them on several, if not almost every single submarine in the U.S. fleet. Pretty cool pictures. Unfortunately, I can't tell you what those things do. So I always like to start off with kind of like an icebreaker. You might have seen this before. You can actually go on Google and find it. I just find this is a kind of an amusing image when some people who don't understand or trying to bridge that gap between the electrical and mechanical space. This is what a mechanical engineer might picture when talking to an electrical engineer about their schematics. I personally like the flux capacitor we have down here, a little Back to the Future. So the typical design process that we see, that I'm guilty of too, that I've used in the past, is we draw out our symbols, we add text boxes, or we actually assign manufacturer part information to those symbols or boxes. And then after the fact, we have to document everything outside of the software in something like Excel. And we build our bill of materials and our to-from wire list. And then we have to go in and we have to audit that and make sure everything is correct and second check or even third check that. And what I find, and that I've done in the past, is that when I do this, that process never really ends. We have to go back and we have to cycle through that again and again. And before you know it, we're already ready for the next project. Well, what SOLIDWORKS Electrical allows you to do is it allows you to take a lot of that back-end information, that reporting, those bill materials and to-from wireless, and a lot of that auditing with design rule checks, and bring it up front while you're doing your design, so you don't have to sit in front of Excel for a week to make sure you've got all your parts. So as you build your schematic, you're building everything up, and it's a more efficient process. The key factor with SOLIDWORKS Electrical is, in my opinion, is the shared library. No pun intended with this keyed connector here. But we can actually represent that connector in several different ways throughout our schematic, as well as the 3D side when we connect to the 3D portion. And we see here I have 4 different ways to represent this particular connector, with a line diagram, a detailed schematic symbol, the 3D part, and even a 2D footprint. And we'll get into a little bit of each one of these. So as Joel mentioned, it is Friday, a little early in the day, but it's almost beer 30 somewhere. So we're going to take this and we're going to talk a little bit about beer. And how does this relate to SOLIDWORKS Electrical and even the mechanical space? So if you've ever tried to brew beer before, you might have seen something like this, where you've maybe got it as a Christmas gift or something like that, or a birthday present, a beer kit. Well, usually this is how people get involved in the brew process, something like this, and it piques their interest. And then they might go in and invest in something like this, which is a couple 5-gallon buckets, and actually make a whole batch of beer. This is actually what I have. I have this kit right here. When I get a chance and my wife doesn't complain about the smell, I'm allowed to go ahead and brew this in my kitchen. But then you can go ahead and take it to the next level, and you can actually go ahead and build an actual legit cabinet like you'd see in maybe one of your shops at work, some sort of thermostat controlled cabinet that will control all your kettles. Well, what I've done is I've taken an example like this, and I've actually turned it into a digital representation. That's what we're going to be working with today. So not only did I mock this up, I went in and I took this cabinet and I took all the pieces and I essentially reverse engineered it. And I turned it into a digital, again, another digital representation. So we're going to go in and actually go ahead and work with our schematic and eventually show how we get to this point with all of our routed wires. So what I want to show you today is we're going to go ahead and we're going to work with first we're going to do the electrical mechanical collaboration, and then we're going to go in and streamline our process with some of the intelligent functionality. We're going to show how the 3D side communicates, and then finally go in and show the project deliverables, ultimately the meat and potatoes and what we really want. We want to capture all this data and be able to create a PDF or other type of file for external consumption. So the electrical mechanical collaboration, let's dive into that first. What we're going to do in this little section here, I want to talk about just a second how the two sides connect. Where do we connect, and how these two sides really are communicating on the back end. And then we're going to go in and we're going to start working with our schematic. We're going to talk about our detailed schematic as well as our line diagram and show how those connect back and forth. And then we're going to talk about our wires and how they're not just lines on our sheet anymore. So I'm going to start with SolidWorks, core SolidWorks. Many of you have probably seen this. If not, we're going to start on the 3D side so you have a better idea of how things are connected. Here is our here is our example here, our brewery. And as we can see, we have our cabinet. All the wires are routed. I'm going to go ahead and delete those in a little bit. We'll see that and we'll reroute them. But one thing we have here on the mechanical side is what we call the projects manager. Now, the projects manager is where all of our collaborative projects are controlled from. This is where I would open up a project or duplicate a project or save it off. But this is where we can see that first instance of collaboration between the two sides. And in this case, it comes up in blue. It lets me know that I have the project open. In this case, the 3D side. But we'll see this a little bit more in just a few minutes when we jump over into the electrical side. Because I have this project already open, in our right-hand side here, we can see the project tree. Now, the project tree is totally customizable however you want to set it up with the main project. It's books. Let me zoom in here. We have our books. We have different folders. We can have subfolders, and you can organize that however you desire. If you have a company standard, you can set that up as needed. Now, the nice thing with this is that I've broken out my my schematics and my spec sheets and everything in separate folders. And when I say spec sheets, one of the nice things about my spec sheets is that I can embed them right into the project. So that way, it popped up on my other sheet here, my other screen. What I have here is the ability to embed these PDFs or Word documents or spreadsheets right into the project. So that way, everybody has access to it, not just me on my computer. I don't know how many times in the past that I've gone to a website and I've downloaded the spec sheet. It's in my downloads folder, or I move it to somewhere on my server. And then 2 weeks from now, I'm trying to find it, and I got to go back to the website and download it again because I have no idea where I actually put it on my computer. So this helps prevent a little bit of that, as well as being able to share this information, the pinout information for a lot of our parts, right in the project itself. So nobody has to go hunt them down later on. It's a nice little touch. Within our schematics, we can actually go ahead and open the sheet and view from the mechanical side. We can take a look at what our schematic looks like. We can't edit from this side, but we can at least see the progress being made in our schematic. So now that we've seen this and we've got our assembly open here, I'm going to go ahead and jump over into the electrical space. I'm going to open up a brand new instance of SOLIDWORKS Electrical. And one of the first things that shows up is our projects manager. Remember, I showed before it was in blue. This time it's in red, letting me know that somebody else is working on this project, because we can work concurrently with both mechanical or additional electrical engineers. So we can see here that I do have another user. Obviously, it's me on my computer here, but in a network situation, this would at least alert us, letting us know somebody else is working on this. Get a little quick warning, we can accept, and just like that, we now have that same document tree that we just saw over on the mechanical side is now available for us on the electrical side. And we can see the files that I have open on the mechanical side are in red, letting me know that that somebody else might be working on those. So first thing we'll do is we'll go into our line diagram. And inside of our line diagram, now this type of sheet here is what I like to use it for, is kind of a general overview or block diagram of my overall schematic. I don't necessarily need to show all of my pinouts here, but these are the main components that maybe my customer needs to be aware of, or pass this information up the chain to somebody who might not necessarily care about the detailed schematic information, but kind of wants a general idea of how things are connected. So this tool here will allow you to generate this, as well as starting to build your bill of materials without getting into the nitty gritty of all the pinouts for every one of your connectors right now. So the first thing we're going to do is we're actually going to go ahead and add additional XLR connectors for our sensors, our temperature sensors in our kettles here. So I can, if I wanted to, I could use the old Control-C, Control-V feature, or I can also go to Insert Symbol. But to save some time, I am going to use the old Control-C, Control-V feature and drop this into place. Now, if you notice, one thing it did not overwrite an existing part. It created a new component inside of my project. The same part information is there, but it created a new instance. So in my bill of materials, I now have 2 of these. We actually have 3, and I'll show you why in just a second. But I have 2 right here. So in my bill of materials, it's not overwriting anything or just copying. It's building on top of what we already have. So when we go to order this later on, I now have these 2 right here. So let's take that another step further. And I will go ahead and add an additional one as well. And I'm going to connect these up. Now to connect these, it's very simple. I'm going to draw a cable and draw a cable. Just like that. I've made the connection between these 2. I can also assign cable information, but we'll get into that later. So now what I want to do is I actually want to change the naming convention on these parts here, because XLR5 doesn't really line up with XLR1. Well, I've already gone ahead in my actual detailed schematic and I've added an additional XLR. Just take a look at that real quick. So XLR1, I've already got in my line diagram, and I have XLR3. I actually want to take XLR5 that I just added and rename XLR5 to match what I have here as XLR3. So let's go ahead and do that. In order to do that, I simply need to go into my symbol properties, select XLR3, and I've now taken on the properties of that particular part. I'm going to do the same thing for this one here. And I'm going to change the numbering convention for XLR5. Now, why did I do that? Well, one is because I want to assign this line diagram symbol and match this schematic symbol here. Now, why would I really want to do that? Well, I can have, as I mentioned earlier in the PowerPoint, is that I can have multiple symbols associated to the same component. So if I'm working with something like a 30-pin connector, I can actually have multiple symbols associated to that one. I don't know about you, but in my experience, I've never had really unless I'm using a vertical piping sheet, it's kind of hard to fit all 30 pins on one sheet. Usually I have maybe my line, neutral, ground on one page, a couple additional pins on another page, depending on what they're being used for. So in this case, I can assign multiple symbols to that one component. And very quickly, by using what we have it's essentially a hyperlink, I can use this go-to feature, and I can go from sheet to sheet and look at all of these different parts. So in this instance, again, I've only got 2 symbols, but in reality, I could have, if a 30-pin connector, I can have 30 different symbols or more if I have a line diagram as well associated to that one particular component. And if I change the information here, it will change on all of those symbols. So now instead of having to go from sheet 1 to 10 to 12 to 16, if I change one instance, it will change all of them for me. So it catches all that information. So again, it's less manual entry that I have to worry about later on. So I've already drawn some wires on this connector here. And one of the things about our wires is they're not just lines, and I'm using my air quotes here, they're not just lines in a layer anymore. They're actually, there's some significant properties built into every single one of these wire types. If I go ahead and select that, we can see underneath the wire properties here that I do have some information correlated to the 2D, the schematic itself. So in this case, it's a blue control line. I do have a formula, which we'll get into. But more importantly, I have 3D information. So in this case, it's a 22 gauge blue wire. And if I'm working with something like fiber or a pneumatic hose, I would want to put a bend radius in here. So that way, when I route this in the 3D space, I'm actually going to get a bend that won't force, it'll force the wire or the fiber or the hose to have a larger bend radius to prevent anything like crimping, at least a visual aid to help you see that, hey, based on that bend radius, I might need to expand this out, this bend or this around some standoff or something like that. So it's just something to keep to be aware of. So real quick, what we did was we went through the communication and collaboration between the mechanical and the electrical space. I talked about the line diagram as well as the detailed schematic. And I also showed the wire styles that I have with that are already built in that symbol. So a few benefits of this is one of the main ones is, of course, communicating effectively between the electrical space and the mechanical space, simplifying your operations, which we're going to get into a little bit more in the next section, and save a lot of valuable time. So when I say get into the next section here, we're going to talk about our intelligent functionality, things to make our lives easier, things to make our job while designing and drafting out our schematic a lot faster. And the cool thing about this image here, this is actually my boss's image. It's a picture that I took at his house. He wheels this out of a closet into his living room. He moves his kitchen table out of the way, into his dining room, I should say, and brews a beer right there. So he hooks up. You can see the yellow power line. He has a jacuzzi in the backyard, and he disconnects the jacuzzi and runs it into the power for that. Pretty nice little setup there. So within our intelligent functionality, we're going to talk about our macros, and we're going to how we can use macros. Now, not Excel automation, not Excel macros, but macros that I like to call them common schematics, and I'll explain what that is in just a second. Next thing we're going to do is our origin destination arrows and connect our sheets together. And then we're going to talk about terminal blocks and how those can potentially help you get your job done faster, as well as create new ways to show your information. So what is a macro? Well, in SOLIDWORKS Electrical, a macro is again, like I like to call it a common schematic, something that I'm going to use over and over again. So with that said, what I can do with this particular symbol here with these wires is I can save all of this information, all of this metadata, and save it off into its own library for reuse later on. Because 9 times out of 10, I've done it in the past where maybe my input circuit is the same from project to project. I'm comfortable using a particular power supply. I'm comfortable using an EMI filter that we know is compatible with whatever components we're working with downstream. Well, we can create an entire circuit and save it off for reuse later on. In this case, I'm just going to use one connector here. So I'm going to use this XLR3. Make sure I highlight the whole thing. And I'm going to go ahead and save it off into my macro palette. I can give it a fancy name, add it to a library, and now when I'm ready to use it, I simply come in and I drop it into place. And just like that, it's captured not only the symbol, not only the wires, but all the metadata, the manufacturer part information built into this. Now, if I'm working with something like what's a good example? An Amphenol connector. An Amphenol connector has the housing, the pins, the back shell, the extender, a piece of heat shrink. Those are all parts that you need to account for. If you build that into the first time, you can save it off as a macro and reuse it later on. And now you don't have to go in and rebuild and add all of that information that you need to account for. I can't count. I probably can count how many times. I choose probably not to even say how many times I've forgotten them, but how many times I've probably forgot to order the pins with a connector, only to find out that there's like a 2-week or 3-week lead time on them, and now I got to explain how or pick a different connector. It's just to save yourself some time. It's the easiest way to do it is build this symbol once, add the parts that you want to it, create a macro, And now you have all that information in there, because when you save it all in this macro, when you create your bill of materials later on, it's going to be in the bill of materials, so you won't forget it. So let's go ahead and change XLR7 to 5. And just like that, I now have my connection back to my line diagram as well. So now that I have these here, I'm going to steal one of my coworkers' jokes. We have electrons kind of spilling on the page here. They're not really connected to anything. So let's go ahead and connect those up with what we call origin destination arrows. Now, in order to do that, we have this fancy window here, this manager, where we can connect different sheets. We set them up side by side, and we can connect our wire styles together. Now, one thing about the wire styles in here, remember I said there's properties built into those wire styles. Well, if I select this blue wire here, and I go to select the green or the yellow wire, it will not let me select them because the properties for that wire style are different. So it's a nice little design rule check that forces me to, oh yeah, I can't connect to this one. It's not the same wire type. So we can go in and we'll just drop that in, and I will go ahead and add the rest of these up real quick. So the nice thing with doing these and adding these origin destination arrows, well, one, you don't have to fit everything on the same sheet. But the other part of it is that these are also hyperlinked from sheet to sheet. A simple double click and it will take me to the opposing page. Now that's all well and good in the schematic tool, but the really nice thing is that when I export this to a PDF, these are also hyperlinked in the PDF. So somebody who is not using SOLIDWORKS Electrical can now view this instead of handing somebody that giant 11 by 17 book and saying, here you go out in the field, have fun. Now they can have a PDF or a ruggedized iPad while they're working on a cabinet or inside of some type of unit, and they can simply double click that and it will take them to the opposing end and they find the information they're looking for a lot quicker than taking 10 minutes to search and follow that line across from sheet to sheet. All right. So the next thing I want to do is, besides origin destination arrows, is our terminals and how we can create a terminal block drawing. So I have our PLC here, and I have a whole bunch of wires here that I want to actually drop in a terminal between here, terminal block, I should say, in between here. Now I have two options. I can go in and I can add one single terminal, or in a case like this with big ladder, I want to go in and drop a whole bunch at one time. So very quickly, I'm going to go ahead, drop these in, determine what side is pin 1. Typically, the PLC is in the cabinet and pin 1's on top. So I will go ahead and select this particular side. And just like that, I've now added a new terminal block to my project. Well, that's all well and good. But I can also take this information and I want to display it slightly different. Well, let's go ahead and add some more information here. I'm going to actually take, just for all intents and purposes, I'm going to take these 3 wires and I'm going to, maybe just these 2 right now, and I'm going to take those and associate them to a cable. So now I have a cable built into my particular project here, as well as wires connected to this terminal block. Now, why did I do that? It really doesn't make sense, but I really want to show you what the potential is on why I did that. So I have my terminal block here. We can read this on a schematic. Obviously we can clean up some of the font here, but what the nice thing is I can go in and I can draw this terminal strip. And now I have a different way to represent this particular terminal block, a good starting point in our cabinet. We see here that a new sheet has appeared in my project. And I now have a terminal block with a lot of information in here that might be easier to read. So somebody out on the shop floor who's building this cabinet for me, or taking this information and building a chassis or whatever it may be, I have the terminal block. I have the to from information going out. Where is this connected to? But additionally, what you can add, obviously bridges as well, but I can go in and now I have that cable, that fake cable I brought in there, but I can show the two wires connected to that cable from the terminal blocks, the wires back to the cable, turning back into wires again, and to the peripheral components on the other end. So it's just another way to show the information that you have in your schematic to provide this, maybe again, to the shop floor, to a subcontractor, to a customer, so they have a better understanding of how things work without having to really give them the schematic. So real quick, to cover the intelligent functionality to help us get our jobs done faster, we covered those common schematics, those macros. We then went ahead and we did the origin destination arrows. Oh, I didn't show this part, but I can go back and cover that later. Very straightforward. And then we went ahead and we did the terminal block drawings. The benefits of this, of course, is eliminating a lot of manual steps. Nobody wants to go in and drop in a symbol, add the metadata, all the manufacturer part information, draw wires out, and then repeat that over and over again. If you're working with something like a microfit Molex connector, a 4-pin microfit, and you've got 30 of them, do you want to do that over and over again? Even though the information inside that is the same from part to part, the use might be slightly different, but the manufacturer information is going to be the same. So create that macro and get your job, just drag and drop it in as you need to. It makes your job a lot faster and a lot easier. So simplifying your operations is obviously a huge benefit, and increasing your visibility, because now you can push that information like those terminal block drawings out to additional people, different groups. So we're getting a little closer to getting to the routing. Let's go ahead and take a look at how we get to that point with our 3D models and showing the routing capabilities. So the first thing we're going to do is we're going to go ahead and insert our parts and also associate our parts. And then I'm going to take a second just to show you what how the electrical side talks to the mechanical side. This is I call that enlightening moment, that moment where we can actually understand how the two sides, what is forcing these two sides to really talk, and we talk about our connection points. And then we'll go ahead and we will route our wires in the 3D space. All right. So first thing we're going to do is we're going to open up our assembly. So let's jump back over into the mechanical space. We have our cabinet here. I'm actually going to go ahead and remove that because it's already there. And we're going to reinsert that connector. So if you remember the manufacturer part, that key factor that I showed from the PowerPoint earlier, is that manufacturer part also has a solid part associated to it. So in my component tree, when I assign that manufacturer part to that J1 that we have here, was it J1? It was J2. There it is, J2. I actually have J2 here. It has that part built into it. So what I'm going to do is when I select insert, it's going to go to my library, find that particular solid part, and pull it out into my main assembly. Now it's simple. Drag it over the spot where I need it, and just like that, it snaps in. I do have SmartMates set up to this, so they will snap into place with the opposing connector to make my life a little bit easier. So this is something that is extremely easy, that the mechanical engineer can just go in and set the SmartMates up one time, because those SmartMates are set up, those smart references are set up inside of the part, that the electrical engineer doesn't need to know how to do a lot of this information on the 3D side. They can really stick to the 2D side, but if they want to help out, they can start dropping these parts in very easily. Obviously, if they know how to use mating, that's great. But with the SmartMates set on, I just drop that in, one click of the mouse, and it's now snapped in place. And we can see that I have a checkbox letting me know that that part is now in its correct position. Now, with that said, there's an additional way that I can set this up. Maybe the mechanical engineer has already gone in and added all my connectors for me, so I don't have to go in and do any of that. Well, inside of my parts here, there is an option where I can go in and associate. So if that if the insert is not an option for you, now I can come in and select associate. It will allow me to see which parts are still available for me to select, to choose. So in this case, I'm going to choose this XLR connector as XLR3, a simple enter key, and I've made that association. So it's even easier than inserting if everything's already built into that assembly. I'm going to go ahead and do the same thing for XLR5. And now we have that. Pretty straightforward. So I'm going to back out of my top level assembly and I'm going to go into my sub-assembly with just the cabinet. I can break out my assemblies, which is very convenient, based off of my locations that I have on the electrical side. So if I'm working with a really large project and I want to set up, and I have five different cabinets that are almost identical, I can set up different locations and break those out into different assemblies and correlate that information. This is more of a training thing, but just something to keep in mind that you can organize this based off of different sub-assemblies and correlate those to the different assemblies you have that you might have already built. So now that I have this set up, let's go ahead and take a look at our individual component here. Now, each component has connection points that we need to set up. This is where, again, my air quotes, this is where I would go in and set up my part and make it electrically intelligent. We would follow the routing library manager and we would follow the steps. Essentially, it's a C point, but it has electrical information associated to it to the particular manufacturer part. These points here point to specific points within our parts. That's what these points are. This isn't obviously the safety relay, but we can see that these points here correlate specifically to those connection points here. And that is how the electrical side is really talking to the mechanical side, by looking at these particular points here, and it allows you to route from point A to point B. I find that one of those points that people finally go, oh, all right, I get it. I understand how those two sides are connected now. So let's go ahead. Now that we have all of our parts associated, we have our connection points built into all of our parts. I'm going to go ahead. I'm going to suppress these real quick. I'm going to go ahead and route our wires. I'm going to use sketch lines, but just so we can see, you can make it a little faster for us. The different options when we can go ahead and route wires, we can route cables and harnesses. In this case, everything in here is a point-to-point wire. So I'm going to go ahead and do a 3D sketch route. Why do I want to do that? Well, one, it's a great way to find out what my path is going to look like right off the bat. If I do a full solid route, you'd be sitting here watching me, watching the status bar for probably a good, I don't know, 4 or 5 minutes watching the status bar. But that is a heck of a lot faster than sitting here trying to manually route every single one of these wires with C points and the electrical tab that I have at the top here. So I'm going to use my sketch lines. I'm going to go ahead and just do all the components, and I'm going to let the system do everything for me. Now, there is an additional step that you need to do while you're working with this, and that is we call our EW path. It is our guideline that we need to set up and let the software know where we want our wires to route. And we'll see that appear in just a second. Now, why do we want to set that route up? Because we want to route from point A to point B, but if we don't have this particular route path set up, it's going to route wherever it wants. You have not told it to say, oh, I want you to follow this particular piece of panduit, or I want you to add an extra 3 inches because of the hinge on the door. So these are things that you need to account for with this EW path. It is essentially a 3D sketch that we convert and call EW path, and that's what the software looks for. So just another second, we should be able to see what our sketch lines look like. And actually, we'll be able to see that EW path as well. Now, keep in mind, I'm not doing anything. My hand is off my mouse, off my keyboard right now. I am letting the software do everything for me. It is looking at every single one of those parts on my 3D side. It is looking at all of my symbols over on the 2D side and looking at those wires that I have, the to from information, and routing everything for me automatically. Just like that, now I have all my wires. And we can kind of see, if I scroll to the back here, it's a little bit easier to see. You can kind of see these rigid yellow lines. Those are my EW path. Those are the lines that I would set up to kind of give my wires a guide to follow. And you can kind of see from my terminal blocks here how they follow those lines to and from where they need to be. Pretty straightforward. So real quick, what we did there is we went through and we inserted a part as well as associated our component to an existing part that's built into our assembly. Talked about our connection points real quick, and then we went ahead and we routed that information in 3D. And you can see with the sketch lines, it's pretty straightforward. It's pretty quick on routing those. Again, doing the full solid route, it does take a little longer because you're adding a full solid to every single one of those wires. So it's the computer is processing. You can hear my computer over here. It's chugging the fan. It's chugging away over here while it was running through that. But the benefits of this is being able to increase visibility, simplify your operations, as well as save a lot of valuable time. Nobody wants to sit there and try to manually route every single one of those wires. Now, I say increase visibility as well is because two things. One, if I go ahead and route this, I can now take a screenshot and tell the folks on the shop floor or a customer or subcontractor, say, this is my design intent. There's a reason why I separated my power versus my comms. So there's a reason why I want you to route all my power on the left side of the chassis and all my comms on the right side, and so on and so forth. Or maybe I go ahead and route and I show this to my customer. That way they can see the progress without having to build a full prototype and even see pictures and a status. You can route and say, hey, this is what it's going to look like as we get further down the road. So we're just about there. We're getting ready to fill up our kettle, but we got one more thing to do. We're going to go ahead and generate our project deliverables. And the first thing we need to do is number our wires, and we can do that automatically. And then we're going to go ahead and generate our reports, and very simply take a look at those reports. So back over on the electrical side, let's find a good sheet to work with here. Here's a good one. All right. I'm going to go ahead and number my wires. Now, if you've ever done, so for the military in the US, every cable, every wire, every harness has to have a number on it. Doesn't matter, and it's this long digit that has to be associated to that. Now, if you've started a project, and I'm going to start with sheet 1, and I start working my way down through all the wires, and then somebody comes out and says, oh, there's a big change that needs to happen, you might as well just delete all your wire numbers and start all over again. Well, with SOLIDWORKS Electrical, you don't really have to do that, because inside of every wire style, there is a formula built in, and I can set that formula up to say whatever I want it to say based on specific information that I call out. And by setting up that information in that formula, I can now come in and say, number new wires, take a deep breath, maybe 2 breaths, and all of my information is now on those wires. And if something changes, well, I can go in and I can delete them, or very simply make a change and renumber them again. So instead of sitting there for a week straight trying to number everything, now you can go ahead and number everything in 10 seconds rather than a week. So now that we've done our wire numbering, let's go ahead and take a look at some of our reports. So inside of the report manager, I have several report types here set up, but there are also additional reports that I can add to this. Depending on the complexity of my project, I have a lot of different information that I can add to, or not information, I can populate information. It's all the information from my schematic. It's going to pull that information out via a SQL query and create this report for me. Now, we're going to go ahead and we're going to create a bill of materials, a to from wire list, and very simply, I'm going to go ahead and select a few of these. Let's see, I'll do the cable. There we go. And I'm going to, again, let the software do everything for me. And if you notice on the left-hand side right now, all of my sheets are being generated for me without having to go and sit in front of Excel for a week and make sure I've ordered enough connectors. So we'll give this 15 seconds or so to generate all this, and then we'll go ahead and take a look. Now, one thing about the reports is that they are customizable. So if there's specific information that you want to capture, you most certainly can grab specific information from your connectors and pull that into that particular report. I know of a few customers, one in particular, that they build 2 different bill of materials. Actually, they build a few more, but 2 in particular. One report is for the folks on their shop floor. The other report is for their logistics team, the procurement team, who is going to buy the parts for them. The guys on the shop floor don't really care where you got it from. Did you get it from DigiKey, Mauser, Newark, whoever? They don't care as long as they have the part and know where to put it. But the procurement team, they need to know what the part number is and the DigiKey's part numbers, for example, and where to get that from. So we can go ahead and take a look at these types of reports here. And again, as I said, we can organize these. We can sort these however we want, based off of location, based off of mark, based off of quantity. So the sort, how you sort them is totally up to you. So next thing I'm going to do is take a look at our wire styles. Let's see here. Let's take a look at this one. And in this particular case, essentially it's a to from wireless, but it's giving us a little bit more detail than just where it's going and where it's coming from. It's giving us our wire number, the section, and more importantly, even the length. Because we routed it over in the 3D space, we can actually capture that length. Now, a quick story. I think Michelle's probably heard this story. So back when I was a defense contractor, I've gone ahead and I actually was involved in this big project out in Guam. So from Connecticut to Guam, it's 26 hours to get there. There was a team of about 4 or 5 of us with all this equipment. Well, before the trip, getting all of our stuff together, my boss asked me to order a 60-foot RF cable from Megaphase, which is a company that makes really nice RF cables. So I ordered this cable. This cable costs about, I want to say it costs about $16,000 for this one cable. Okay. So with that one cable, we take everything and we ship it out to Guam. We get on one of the submarines. We put everything on the boat, and we're starting to route that cable. And we get down to the boat, the room where we need to hook this cable up, and it's like Doc Brown from Back to the Future, where he's about a foot short and he can't connect the 2 sides together. So if we had routed it in something like this first to figure out a length, it would have saved the ridiculous headache that we had to endure for the next 2 weeks waiting for a new cable to show up. Luckily, my boss took the brunt of the battle on that one, because he told me to order it. So, but if we had ordered a 62-foot cable, it would have saved a lot of pain. I got to sit out in Guam and go snorkeling for a week, so I can't complain too much. But it's just one of those stories that it would have saved the company, it would have saved the government a lot of money, because there was a screw up with how long that cable came in. So with that said, we went in and we numbered our wires, we generated our drawings, and we took a look at those different types of reports. And again, the reports are totally customizable. There's a lot of information you can pull from a lot of different parts. It is pretty strong and fast how you can get these reports to come out. So the benefits of that: simplifying your operations, saving valuable time, and eliminating a lot of manual steps. So real quick, over the past hour, we've gone ahead and we worked with our communication and collaboration, those intelligent features, the 3D space, and then our reports. The main reason why we're building all these is to capture all that information, all those reports. So the benefits, I can't stress this enough, is that communication and collaboration. You saw from the video that Michelle showed earlier, the cartoon video, the communication it grows tremendously. We see a huge increase in communication with our customers that are using this tool. A few additional points that I love to bring up is is where do we get our parts? Well, we have what we call the electrical content portal. This is where you can go in and download zip files of particular manufacturers that you might use. Instead of going in and building everything manually, you do have that option of going in and downloading these zip files and adding those to your library. You also have 3D Content Central to capture a lot of the 3D parts. And then finally, mysolidworks.com. I'm an electrical guy. MySolidWorks.com has always been geared towards the 3D space. Well, in the past 2 years now, we've really increased the electrical side of things and trying to get videos up there to help you get your job done on a daily basis, where maybe you've gone through training, but you forgot how to edit a symbol, or you forgot how to add certain information or change attributes. There's little videos in there, little vignettes that can 2-minute videos that while you're working, you can log in, check out the video, and get right back to work and do what you need to do. I find myself using it more and more as well, I'm the one helping build a lot of these videos too. So, but in general, I find a lot of useful information on mysolidworks.com. We do have the ability to collaborate with PDM, and it is getting better and better and better every single day. We have new updates on that as well. It's not just for the mechanical space anymore. And then another thing to think about is, who else can I share my information with? It's not just about electrical and mechanical anymore. There's a lot of other tools out there that we can look at and take advantage of to really bring everything under the umbrella of being able to pass our assembly to Composer for training material, MBD for machining, the SOLIDWORKS PCB tool if we have circuit boards, of course PDM for management, and even Visualize for marketing material, which is really cool if you haven't seen it. And if you want to see this a little bit further, we actually did a YouTube series on, that's my boss behind me, the bald guy in the back there. That's his brew set, and we did a whole video series using this particular data set and how we correlated SOLIDWORKS Electrical to the brewing process. So if you ever want to check it out, it's like 5 or 6 videos called Brewing with Electricity. You'll see my big head right there, and you'll see me narrating the process and how we use the brewing setup. So with that, I want to thank you for joining us here today. And that's of course me drinking a beer. So thanks again. And Michelle, I don't know if we have time for questions or if we want to, that's up to you.
So I don't have any questions listed in the panel, so I think I'll just let Joelle wrap things up and
all right.
Go from there.
All right. So great information as always, JP. Thanks for joining us. We appreciate you taking the time to spend with us, northeastern Canadians, and sharing this. You have made me thirsty, and it's perfect timing for lunch. So so the timing is good on this. We plan these things, right? So so that we know. So a lot of keywords that we all love to see. A lot of keywords that your management probably loves to see in terms of collaboration, standardization, simplification, reduced errors, just time savings. Overall, the reporting is unbelievable. The numbering of wires is a huge time saver. How many times have I seen people with their books and going over them line by line to make sure that the numbering is correct? None of that needs to be done with electrical, so it does it for you. If you want more information, the video series that JP mentioned is a great one to see for fun. But if you want to see how this could apply to your business, how this could apply to you personally, then you will need to work with your reseller, and they can definitely help you in that area and show you exactly how this would apply to you. So you can always reach out to us as well. If you want to share this video with someone else in your company who you think would need to see this, it is recorded, so you can either do it from the QR code there, or go to the channel where we have all of our recorded webinars, so that you can tap into the information that way. The link you got to get onto this webinar can also be shared and reused. The recording, it will lead people right to the recording. So lots of ways that you can see this info. Obviously, there's the SOLIDWORKS website. But once again, if you want to see how this will apply to you, a reseller will be the best resource for that, to discuss it with you, analyze it with you, and if they need, they'll bring JP in, and we'll all help you figure out how this works. So with that, I wish everyone a great day, a great beer if you're going to have one to follow this, and thanks again, JP, for doing this. Thanks, Michelle, for doing all the logistics behind for this. And we wish you all a great weekend. We'll see you on our next webinar.
Thank you,
Happy Friday,
everyone. Thanks,
everybody.
JP.
Bye-bye.